OK, let's talk now about the second half of implementing the AsyncTaskBarrier framework. And we're actually going to take a closer look at how it works under the hood. And we'll see the various Flux and mono operators that are used to implement this, especially the runTasks method. That's what we're going to focus on. And we'll see when we look in the implementation in more detail, when we actually look at the code, that there's some very subtle behaviors between onErrorContinue, onErrorResume, and onErrorStop. We saw that with the unit test that we ran earlier, and now we're going to see it again when we look at the implementation. So we're going to go ahead and take a look at the code in a minute. Here is basically, at a high level, what things do. So you can see the register and unregister methods are simply going to take suppliers to monos to voids. These are the method references we're going to pass in for the methods under test. And we use mono to void so that that can signal to the AsyncTaskBarrier when we're finished. Remember, mono to a void is used with then, and it's a suppressing operator, so we just want to say we're done. That's basically it. And you can also see that all these methods do is just add and remove the task from the list, so there's nothing too profound about that. The runTasks method runs all the registered tasks. Here's what it does. It's going to return a mono to a long that will trigger when all the tasks complete. And it's going to omit the number of tasks that completed successfully. We'll see how that works. That's very important, and that's why we have all this complexity with onErrorContinue and onErrorResume and onErrorStop. The first thing we do is we take that list of registered methods, which are the tests, and we turn that into a Flux. So this is just good old from iterable, one of the simpler factor methods. Then we're going to use flat map, and essentially for each of the methods under test in this Flux stream, we're going to call their get method, and the get will then invoke the method. So it's going to go ahead and run the method. And now that's what's going to typically, if it's using things like subscribe on or parallel flux or whatnot, that's going to start running in the background. And each of those methods will then return a mono to a void, which are kind of funky things to return, as we'll see. We then use onErrorContinue to log any exceptions and continue the processing. And when we look at the code in more detail, I'll show you how this works. It's pretty cool, but it's subtle. Then we collect everything that has finished, and this is really wacky. So it turns out that when you run methods that return monos to void, there's actually nothing in the list. So we end up with an empty list, but it's necessary to basically trigger everything. So that's what's going to cause it to run. The collect list method is going to be used to make this whole thing work, and we get an empty list, but everything will have run at this point. And then we're going to use flat map, and this is completely crazy, to take the number of tasks that were in the original list of tests we were starting, and we're going to subtract from it the exception count. And every time an exception occurs, we're going to log the exception, increment the exception count by 1, and then when we're done, we will subtract the number of exceptions we got from the original number of tests we were running, and that will tell us how many of the tests actually succeeded. And if that sounds a little convoluted, it is, and we'll take a look at that when we look at the code here in just a second. So here we are in this project. We're going to take a look at the AsyncTaskBarrier implementation. We walked through this before, so I'll skip over some of the things like register and remove. Sorry, register and unregister, they do obvious things. But let's take a closer look at runTasks. We didn't really get into this in enough detail when I walked through the slides at a high level, but we're going to take a look at how error handling and exceptions are dealt with now. So first thing we're going to do is we're going to make a new atomic long that will keep track of how many exceptions occurred. Atomic long is probably overkill. We could have used atomic integer, would have worked just fine. We're then going to make ourselves an error handler by consumer, which we're going to pass to the onErrorContinue error handling method. And this is going to log what exception occurred, and we're going to increment the exception count by 1. Very important. So whenever an exception occurs, we increment this count so we know that something's gone wrong. Then here's the main Flux chain. This is very similar to what we looked at before. However, now that you know what the error handler looks like, now that we know what this particular by consumer does, especially how it increments the exception count, you can see that whenever an exception occurs, it's going to increment that count by 1. And therefore, after all this processing is finished, down here, we will take the size of the original set of tests to consider, and then we subtract the exception count. And that'll tell us how many tests actually ran successfully. So that's the implementation of AsyncTaskBarrier. Now, what's interesting is if you were to take a look at the RxJava version of this, which we will not do, but there's videos out on my website that show this, it's a little different because the semantics are different. The types of things you have to return are different. They don't have the concept of a mono to void in RxJava. Instead, they use these things called completables. But the overall idea of having a single barrier that waits for everything to finish is the same.